Have you been here before? You're running late for work, you round the corner, you got nothing but traffic for miles. Well, I'm Dylan.
And I'm Jack.
And we have the solution for you. Urban air mobility. So what is it? How's it work? So we're proposing an electric VTOL design, so we'll have zero emissions. We want to take a safety first approach, make it fully autonomous, really take the human error out of things. We want to build small stations around your city to support the charging and the maintenance of the vehicles, and that'll also allow us to service not just the interior of the city, but also the outlying suburbs. And then we want to have a companion app, kind of like Uber, so you can go ahead and call it from your phone. It'll be ready for you at the station. All you have to do when you get there is walk on and, let your dreams take flight. So why urban air mobility? We'll reduce traffic in the city, we'll reduce emergency response times, we'll be able to provide significantly faster transport as compared against subway and bus travel. There's no stoplights, no traffic, we can do direct routing everywhere we go. It'll be reduced smog, so increased health benefits for citizens of the city. And it's just a very desirable thing. I think a lot of people would really want to flock to a city that can provide air taxis and all these other benefits. So this is our ConOps. It kind of gives an overview of our project, everything from our communications to where our buildings will be located, and just step by step through the process.
With that all said, I'm sure you're wondering what are the finer details of urban air mobility. So we know what our system will be doing. We'll be transporting people using air transportation. We're going to be navigating through urban landscapes such as New York, or I believe this is Seattle shown here, or some other foreign city. Now, how will we do it better? We'll be faster than all other forms of transport. We'll be more comfortable and less populated than other forms of transport, subways, trains, whatnot. And we're going to be operating multiple flights at a time to be also as efficient as subways, cars, any other transport would be. Constraints we're setting, zero carbon emissions to create a greener city landscape for a more desirable urban area. We're going to be autonomous, and the system will also be adhering to all FAA regulations. All right, so from function to function, we're going to have 4 main stages of our operations: pre-flight, during flight, post-flight, and other external operations that we may need. Things that we want to highlight through each one of these functions: we are going to have multiple layers of communication no matter where we are in the process to ensure that nothing is overlooked. Fast launch and landing procedures so that we can keep our efficiency high. Risk mitigation throughout the vehicle and other areas, especially for the autonomous technology system. And we're also going to be prioritizing comfort to any passengers, both pre-flight and during flight. Moving from our functions to form, some things that we can see on our urban air mobility vehicle. We will be utilizing electric propulsion design to keep our zero carbon emissions requirement. We're also going to be utilizing VTOL technology to ensure the most efficient takeoff and landing procedures. And lastly, we're likely going to be utilizing LiDAR sensors to ensure that our autonomous technology is the most up-to-date and provides the utmost safety when moving through such a dense urban landscape. Moving from this, we also want to highlight some interfaces that are going to be happening throughout our system. Firstly, we're going to be prioritizing the connection with our system to the user. So this includes both the app that they will be using to select their flight location. And this also includes in-flight comfort experiences and also multiple settings where the users can see what's actually happening in the flight so that there is complete transparency. Behind the scenes, we're also going to be prioritizing safety through multiple layers of communications. We will have a communications tower hopefully outside of the city. We're also going to be having each housing station communicate with this tower, and the vehicle will also be sending data to and from the tower and housing stations for the most communication possible.
I'm here today to talk about one of the trade studies we did for our UAM project. So we chose mid-flight traffic management as our design choice. There are a lot of different design choices, but this one impacts a lot of different systems, and so that's why we chose it as the most important. And so these are some of the criteria we used. We used safety, time efficiency, battery efficiency, complexity, and scalability. And so some of the alternatives, the first one is mirroring the street grid. So you would have vertiports placed similarly to bus stops, and this would kind of mirror the street layout and the traffic light system. But instead of traffic lights, you would have roads going above each other and below each other. So you don't have to worry about traffic lights or anything like that. And the benefit of this is that it's very low complexity and it's very high scalability and safety. The low complexity is because street system has already been pretty much tried and tested and analyzed extensively with traffic management, so that would be very easy to implement. And our second alternative is direct routing, so vehicles take the fastest possible routes to the destination and just use altitude difference as collision prevention. This would be very low time and very high battery efficiency, but if you introduce more vehicles into the system, it's not very scalable, and eventually you'll run out of airspace. So the third alternative presents an interesting alternative. It's custom routing. So vertiports would be located in hotspots across a city, and there would be a grid system. So this would give us like a layout similar to MARTA or a different subway system. And this would be very complex because you'd have to kind of develop it from scratch. And that would have a high development cost, but this would be the most scalable and the most time efficient. So this is just a rudimentary topsis using those alternatives. And I assigned weightages, but these can be changed. And according to these weightings, the third alternative was the most efficient.
So now I'm going to get into the nitty-gritty with the money, how this is going to be a profitable business. So developing from scratch pretty much our own UAM system, it's not going to be cheap. First we'll have to do R&D phase, and that's going to be mainly looking into the issue, finding markets, finalizing like how many we should have in a given, how many drones we should have in a given region, the exact systems, and a lot of the preliminary things before we can begin building. We estimate that's going to be in the tens of millions of dollars range. And the prototyping, this is going to be a difficult part where it is having to design our final vehicle, getting a prototype of that, testing it. This is also when we would mess with our control algorithm, making sure that it can navigate autonomously. And developing these would be pretty pricey, and that is in the tens to hundreds of millions of dollars range. Rollout will be a major phase where, for any given city, getting the property for the vertiports, integrating them, building them, setting them up, and then building every vehicle we would need, and then coming up with the routing algorithm for that particular city. We estimate that's going to be in the hundreds of millions of dollars. And then yearly operation, once a city is completely set up, we estimate that's low tens of millions of dollars to maintain maintenance and power to power the vehicles and everything. And so some more specific operational costs. Each vehicle we estimate is going to be around 800,000 US dollars. And so a mileage cost that would cost us is anywhere from 50 cents to $2 depending on battery technology. And maintenance per year for a given city, estimate $1 million or so in maintenance. And so the cost estimates, they do vary greatly based on the battery and how much autonomous vehicles are pursued, the control laws. So the best case is that there is significant investment in battery technology, and that can allow us to make a much lighter vehicle, cheaper air cost. And if there is no technology invested, we might not even be able to get our turbo-electric propulsion system functioning. So the best case for autonomous vehicles is that control laws are looked into and developed, and the worst case would be that they are not. And then for the market, our plans are to interface directly with the users. They call it on an app, similar to how they would call like an Uber or a taxi and go from place to place. And we could also set up contracts with the cities that we're implementing in to get the infrastructure. This would help get a lot of funding for the rollout phase and hopefully drop down costs, as we would not need to purchase the land and develop it as much. And so for the market, how we're going to profit off of this, the worst condition is that, or worst case for us, is that they put heavy money in like public infrastructure and roads. And our best case is that they push towards walkable cities. They try and shrink down roads. And since our vehicle doesn't use roads, it would be much smaller. And as you can see on this graph, this is estimated to be a multi-trillion-dollar market. So there's definitely profit to be had here. Well, I've been Zachary Thomas.
I've been Naveen Senthil.
This has been Urban Air Mobility. Let your dreams take flight.